Imagine stepping into an office where nobody uses a mailbox. Instead, they fold every memo, file, or question into a paper airplane and throw it directly at their coworker's desk. It sounds messy, but for years, this was how most software systems talk to each other. The billing app would send data directly to the shipping service, which would send it to the recommendation engine. When you connect dozens of apps this way, you get a fragile, tangled web that developers call the spaghetti problem. To solve this, we can look to the receiver in a home theater. Instead of wiring your Blu-ray player and satellite dish directly to your TV and every speaker, you plug everything into one central hub that routes the signals to the right place. Without a hub like this, growing a business becomes nearly impossible because adding even one new application requires rewiring the entire system. To fix the office, we build a central mailroom. Now, instead of throwing papers at desks, everyone drops their outgoing mail in one spot and picks up their incoming packages from another. In the world of high-tech data, that central mailroom is a system called Apache Kafka. It takes its name from the author Franz Kafka. But while his books are famous for confusing, inescapable bureaucracies, this software is designed to make information move as simply as possible. Historically, companies let their data pile up all day and processed it in one big, slow mountain at night, a method known as batch processing. Kafka replaces that wait time with a steady, organized stream of information that moves as fast as the events occur. Let's look at how this stays organized. Whenever an app or a website generates a piece of data, like a new customer order, that sender acts as a producer, dropping the message off at the mailroom. These producers don't have to wait for a reply. They just leave the data and get right back to work, ensuring the website or app stays fast for the user. The mailroom building itself is the broker, the central server where incoming data is managed. Inside, messages are immediately sorted into specific folders called topics. One topic for website clicks, another for error logs, keeping every type of information in its own lane. This immediate sorting allows the system to categorize thousands of messages every second, without any manual effort or delays. Most systems deliver a message and then delete it to save space. Kafka does something different. It writes everything down in a permanent record. This record is the commit log, an append-only ledger where new information is added to the very bottom. By writing only to the end, it never slows down to search. And because it's permanent, reading doesn't remove it. The history stays for other applications. This append-only design allows Kafka to handle massive amounts of information with incredible speed, preserving a perfect history of every event that happens in the business. The apps that come into the mailroom to pick up and read those topics are the consumers. Each consumer uses a digital bookmark called an offset to track its place. As it reads, it moves the bookmark down. Since each app has an independent bookmark, two consumers can read the same topic at their own pace without ever bumping into each other. Behind the scenes, a background coordinator known as Zookeeper keeps an eye on the entire operation, making sure all the different parts of the system stay in sync. You can see that efficiency here. A single stream of server logs flows into Kafka and is immediately shared with both an auditing app and an error tracking app at the same time. By giving every application its own bookmark and a permanent log to read from, a single piece of data can power dozens of different services simultaneously without causing a backup. This setup is especially useful when it's time to upgrade a critical piece of software. Usually, switching to a new version is risky, because if the new code has a bug, the whole system could crash. Kafka enables a safer approach called Kappa architecture, running both systems at once. Using Kafka's permanent record, version 2 processes the same data in parallel with version 1. You compare both results. Once proven accurate, you simply switch users over to the new version. This ability to test drive new systems using real, historical data makes software upgrades much more predictable and significantly reduces the risk of a major service outage. In the end, it's a simple journey. Producers drop off continuous streams of data. The broker stores that information in organized topics, using a permanent, append-only log that never slows down. And consumers use their own bookmarks to read that data whenever they need it, while a background manager keeps everything in sync. At a massive scale, this allows a company to route millions of messages every second without the parts ever getting tangled or overwhelmed. By replacing messy, direct connections with an organized hub, Kafka provides the reliable foundation businesses need to keep their data moving at the speed of the modern world.